Hey, it's W5HRO. I have an update. Last weekend here when I was, checking the amplifier out and everything and, showing you that I had 80 watts carrier output, that was during the day. And the thing is, see, there's still a little bit of daylight left here. See how the modulation, well, see, it's not on when you transmit. Well, the sun was so bright last weekend when I was working on it, I actually had a problem and didn't realize it. What happened is, it got to, after I did my video and did all that and got it all finished and everything, I see my finger coming down over the phone camera again. I gotta watch that. But after I, did all the video and all that stuff and I uploaded it, it got dark later on that night. I left all this stuff on because I kind of been burning it in because I want to burn in the old components and the new components, and I want to make sure nothing's going to smoke on it, right? Because this thing's old. So I've been kind of just letting it heat up, letting it stay on, checking it all out. So when it got to be dark, I came in here, I thought, okay, it's time to clean up my mess. I got to get this everything off the island here, like I told you before, because the XYL will get ticked off if I keep it tied up all next week, all during the week, like Monday through Friday. And but I just happened to key the mic, and when I did that, I actually have found two problems. When I did that, I noticed the modulation light would come up for a second, and there was no light, and then all of a sudden it was starting to glow, and I went, huh? Because it was dark and we just had the overhead light over the stove on. I'm like, huh, I didn't notice that before, because like I said, it was daylight. And I listened and I took the screwdriver and I turned the mic up and it was squealing something terrible. What I figured out was I was getting RF feedback into the mic or somewhere. I had the cover off this thing, which I put it on today, and I had it over here on this side. Well, on this side, there's the 6BQ5 final modulator tube, and there's the 6EU7 mic amp tube and so forth, right? And the driver. It's right there on this side. So I was either getting RF just from the mic itself, or because the cover was off the amp and it was just too close to the radio, one of the two. So I quickly put a .01 microfarad cap on the output and the base of the mic that night before I shut everything, before I cleaned up my mess. And I keyed up, it was gone. Well, you know what happened when I did that? The carrier power dropped back down to like the 50 some odd watts where it was before originally. So that 80 watts was slight modulation. That was my peak reading MFJ meter. So it wasn't really carrier power. It was just it was slight modulation on it because I had feedback. So today, here this afternoon, I didn't feel good this morning. I just kind of got around to working on this thing. I had a sinus headache this morning, but when that went away, I started working on this thing late this afternoon. And I was playing with it, and I found where the problems were. The reason it had a delay before, when you would key up, the light wouldn't come on. Then all of a sudden, within about 1 to 2 seconds, it would light up and the feedback would occur. Let me show you. This is what's funny. This was the one main first problem. I had remember that .1 microfarad coupling cap there, from the mic to the grid of the 6EU7 tube. Well, here is that cap. And the first thing I did was I thought, well, maybe this cap, because what I noticed was, and I noticed this before, the reason I realized there was something going on with this was because I started looking at the scope and I'd go, hey, and I'd key the mic, and I realized I'd see the carrier, but there was a delay before I started seeing a modulation envelope. And I'm like, what the heck? So I realized the modulation was being delayed before it actually would come up. And I noticed that when I had that new 100 meg digital storage scope that I bought, the one I had down here before I showed you in the last couple video, or the video before the last, or whenever it was. And I noticed it when I'd go, hey, I thought it was just a delay in that digital scope. It was taking a while to trigger and everything, but no, it was because there was an actual delay before the audio would come up. And it turned out to be this .1 cap. And it's not because it was a .1. The first thing I did was I had one of my little blue disc caps, and I just clipped on. I took the audio generator And well, what I did was at first I took the audio generator, let the tone come up, and I just used a jumper. I just short the thing to make it transmit. This was without the mic hooked up, and I could see the carrier waveform come up, and there was like about a 1 to 2 second delay before the modulation envelope would show. So I took a 0.1 mic cap, a 0.001 mic disc cap, and I just bypassed that 0.1 mic, and I just touched it with the red lead here on the generator, right? And I just touched it and I keyed it, and it was coming up instantaneously. The delay was gone. So I thought, okay, let me get one of those yellow the same cap. I got 47 mics of these, and I also have a 0.00, 0.0022s. I have 0.0047s and 0.0022s. So I tried a 0.0047, and I had the same delay. I thought, well, is that still too big? Because originally I thought it was just the size of the cap, the 0.1, right? I thought there was like an RC time constant with the grid of that tube somehow, and that 5 meg grid resistor, and something weird was happening. It was causing an RC time constant. So then I tried the 0.0022, same delay. I went, wait a minute. I thought, well, maybe it's this type of cap. And I had the polarity right. These things are not polarized, but one lead is connected to there's an outer shield, the foil around the center part, and one of them's the center part. You have to know which lead is which, and I tested these things. The one I had in is 0.1 before I put in there to make sure I had it turned around the right way. And unfortunately, it's just there's something weird about this style of cap. So I dug around and I found a 1 kV 0.001 mic cap. I thought 0.01 mic cap. I thought that's good enough. It doesn't have to be a 0.1. As long as I've increased it from 0.005 to a 0.01, that's good enough to make sure I get enough of the low end from the mic coming through. And so I did that. And I did the same thing with my clip lead, and I just touched it in there. It came up instantaneously. So I realized that if for some reason it's this style cap was causing that delay. So I guess live and learn. Don't use one of these to couple the microphone to the grid of the first stage. It causes a delay, and these were causing a delay. I kid you not. And I put a 0.01 in there, and it went away. A disc cap, a 0.01 disc cap. If I put a 0.01 one of these, it would have had the same delay. So I just put a disc cap in this place. I removed this. That got rid of the delay. So then after I put the shield on this amplifier, I went ahead and I took off the 0.01 mic cap, the base of the mic to ground, because with the amplifier, this microphone has like about a 5 to 6,000 ohm output, because it's got that amplifier. The amplifiers are about a 5 to 6K output. Instead of being like a 5 meg to 10 meg output, it'd be a 10 meg output if you use balanced line. Those elements are 10 meg, but since you're using a non-balanced line, it's 5 meg. That's how they work. That's why Aesthetic always recommended a 5 meg grid resistor or load for these things. But with that amplifier, it's about 5 to 6K on the output of it. So I said everything, but I just thought, well, that with that 0.01 mic cap going to ground on the output of this thing with that 5 to 6K load output on it, it was going to roll it off on the high end too bad. So I removed it. Now, I don't know whether it's because it could have, maybe this cap could have been, because of this type of cap, could have been causing the RF to get into it, or it was because this amp didn't have the cover on it and it was sitting too close to the audio tubes on this side of the radio last weekend. So I don't know which it was. I could pull the cabinet off of it again and put it over here and see what happens, but needless to say, I don't need the bypass cap in the base of the mic to get rid of the RF. Either the case, putting the case on and moving it away from the radio, since this doesn't have a case on it either right now, that took care of it, or it was just because of this cap. One of the two, but I could go back to verify that if I wanted to. And I was trying to figure out what it was, and I even went out in the garage, and that old Courier 23 Plus, I pulled the tubes out of it and tried in here, and it had the same problem. I didn't know what the heck was going on, so I tried all that stuff first. But anyway, what I've done is I've gone through and I've adjusted the load for these things. And I put the audio generator in the mic input, keyed the thing, and I've adjusted the load on the amp and the load on the radio to get maximum modulation, which did drop the carrier power back just a little bit. And now when I modulate, if you can see, the carrier power is about 46, 47 watts. And see what I'm talking? And this is just an RMS average meter. This is not a peak, or this is not a PEP or a peak reading meter. I'll bring the AMFJ back in here when I have time, and this thing should be doing about 100 watts peak now. What I figured out is these amplifiers, the BL100, these things were designed to do 100 watts modulated power. 50 watts carrier power at the most. That's what this thing really is. It's 50 watts carrier out, 100 watts on the peak. Not peak envelope power, but the positive peak. It's 100 watts peak. That's the way these things were designed. So that's what I'm getting now. Like I said, this is not a peak meter, so I don't know how high it's going to come up, but I assume on the MFJ it's going to come up to at least 100. Now here's the thing. Let me show you. Oh God, sorry about that. I got confused here. I meant to put the mic down. I laid the phone down by mistake. That was pretty dumb. But let me show you the carrier power. I've got it set for exactly 2 divisions, right? 2 divisions. That's carrier. Now, if I modulate 100%, it would still be just 2 divisions. Now, look what it does. Now, I'm going to have to put it back on normal because I have the trigger set for when it's on normal. Yay. See how it's flattening off top and bottom? See that? It's actually, the negative peak is going down more than 100% now. Let me see if I can do this, get the right trigger on it with the right tone. See, it's a little bit above and a little bit below the carrier, so it's doing more than 100%. Now I have 2 problems. I have to add the negative peak limiter to get it up above ground so it doesn't, start. What it's doing is it wants to turn the tube off a little bit. And if you look at the carrier now though too, see, look. Yay, I'm getting plenty of forwards modulation on the meter, so that's all working. Before, when I had everything peaked up for max carrier power, I was getting about 52, 53 watts, and it would back way down when I'd modulate. So I just tweaked the loads on the amp and the radio for maximum peak modulation with the audio generator going through, and that worked perfect. But there's 2 problems. Like I said, I'm gonna have to put the negative peak limiter in to get the thing raised above ground so it pushes it a little bit more positive, and it looks like it's squaring off on the top, and it's not. I don't think it's hitting the rail. Here's the deal. What I noticed is I have the D104 set. I know exactly where I set it the last time, and I adjusted it. If you look at the schematic here, let me see if I can get enough light. It's getting to be kind of dark in here. I apologize for setting the phone down like that, by the way. I had a brain fart moment. But anyway, right here, see the mic amp is here. When I put the scope on this, I can adjust the D104 to where I get a perfect rounded square wave. If I turn it up too high, it will start to square off just a little bit. So I've had the mic peaked for a perfect round sine wave here. The problem is when I look over here on the output of 6BQ5 where I was looking at last time, it squares off on the top and bottom. Well, the bottom is because it's hitting the chassis ground. It's going below ground, so I've got to push it up with the limiter. That's the one thing. But I don't know whether it's because it's squaring off here to input to the grid of this tube, or it's just on the output. So tomorrow I'm gonna take my scope and I'm gonna probe around. What I'm gonna do is I'm gonna put the audio generator back in the mic input, put the scope here. I'm gonna turn it up to where I get, I'll raise it up to where I start to see a little bit of square wave, and I'll back it down where it completely rounds it off. Then I'll look over here next. It's either squaring off here or it's over here. It's because it's doing it on the positive peak side, on the positive side too. And I think what it might be, see how they have this .002 cap coming down to the cathode of this thing, trying to get some feedback into it, what they're doing, to that 220 ohm resistor. That could be what's squaring off. The first thing I'm going to do, if I don't see it over here and I see it over here, I'm going to just disconnect this cap just to see what happens. That could be it right there. Or it could be the, because right now, see, they've got on the output of the 6EU7, they got a 470 going through a 0.005 going to a 470. See, like I did on that other modification I did where I did 100K to 100K. Well, they're doing the same thing here. And there's a 10 mega ohm grid resistor to ground. So I don't think it's on the grid of this tube. I think the whole problem's over here. It could be the screen voltage on this tube's not high enough. It could be, that could be where the problem is. Or it could be because it's going through this transformer and the screen on the 6BQ5 RF output tube isn't high enough, and it's clipping it there. So I'm going to have to work on this. So tomorrow I'm going to get the scope and I'm going to look here first, see what it looks like with it rounded off completely here. And if I don't see it here and I see it here, then this is where I'm going to have to work. I'm going to disconnect that cap and I'm going to come up here if that doesn't work, and I'm going to look at this, the biasing, and I'm going to look at to see what the screen voltage is. This thing may have to be triode connected. I don't know. That may be the solution too, but I don't know what that's going to do. It may screw up the way the audio sounds on receive. But I may have to triode connect this tube, which means just short that screen right to the grid of that, right to the plate of that tube. Buck said it may be this cap going down here. So that's what I've got to play with. So you can see what I'm going to do, the solution that I've got to try to find, because I'm sure I can get it rounded off on the positive side. Hey. I wish, if I had the audio generator in there hooked up right now, I could adjust the trigger and get it to where you could see it, but I'll do that when I make the next video. But you can kind of see what's happening. Also, I forgot to replace the meter lights in this. I really do not like this meter. And what I noticed is, it looks like somebody at some point had the plastic cover off. They actually bent the needle. I'm going to attempt to try to straighten it back. It may break if I do. If it does, then I'm going to find a current meter the exact same size and just replace it with a current meter. They used an S unit meter on this thing to, so people could adjust the load and the plate on the back of the amp, I guess to adjust it for maximum, reading or something. So this thing really needs a current meter. So I might actually find a little lighted square current meter and put on this thing to replace it if I break that needle off. If not, if I don't break it, if I can straighten it up, then I'll just leave it alone and I'll replace the lights in this. But that's something I forgot about. Plus this NE2 bulb is awful dim. I'm going to replace that NE2 bulb and try to get this brighter. It's too dim. And I still have not polished the face. I got to take this face off anyway and polish it. I did polish the cabinet up when I first got it. Look how clean this thing is. The cabinet to this 23 is like brand, it's like mint, and there's not one scratch on it anywhere. So it's going to be a nice looking radio. But you can see where I've got this thing now. I'm kind of working on it, and I solved the one problem that I didn't know I had. Then I solved the other one, which was the delay. And now I got the thing forwards modulating like it's supposed to, and I'll see if it's up to about 100 watts when I bring the MFJ meter back in here. This one's just easier to use because what happens is it's got the reflected power, it's the cross needle type, and sometimes I've noticed I've got these double, these barrel connectors on here. Sometimes if I don't get them tight enough, the SWR goes up, and I wanted to make sure I had a good connection and everything, and you can see it barely comes up because I've got that MFJ, that 300 watt dummy load. So it's pretty much a perfect match. I think I measured that. That box is like 53 ohms. It's a little high. That's why it just barely comes up off the 1-to-1. So anyway, but that's a perfect match. That's good enough. So anyway, that's where I am on this, and I've made real progress. So now I just need to track down. I need to get the negative peak limiter built in this thing and track down why the positive peak is squaring off. I don't think it's hitting the supply rail. I just think this if it's not that cap that they're feeding back into the cathode of that tube to that or that 220 ohm resistor to ground, then it's the screen voltages, and I've got to deal with that. It's probably one or the other. It's either that cap that's going down to the cathode, or it's the screen voltages. So it's one of the two, and it would almost have to be. I'm almost positive. So that's what I got to work on next. So it looks like I've got at least one more weekend to work on this. So I'm going to be doing this again tomorrow, and then I'll do another video to let you know what I found. And then there's will be one more weekend after that, because like I said, I got to try to fix that meter, get it lit up, and see the PAL. And I haven't gone through the PAL VFO yet. I'm going to go back over that with my new scope, and I'm going to peak all those capacitors up to get the max output voltage out of it, get it all lined up again. Because like I told you, I need to put that rubber band in that slug on the master oscillator, because if I knock it, the frequency jumps quite a bit. It's because that slug is loose, and it's really loose. So the rubber band should take care of that. So that's all for now. I hope this has been educational. I keep finding these little problems here and there, and I'm solving them. So I solved the main two today. I got rid of the feedback, and I found out I had a delay before the modulation came up because of that type of cap I was using. So that's all for now, 73s. This is W5HR and an O.